Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use our fully integrated environment Fidelity in short videos of a few minutes. Today we'll discuss how to use AutoSeal to automatically create surfaces to fill gaps and holes and create ready-to-mesh watertight geometries. We start with an automotive sample geometry which was imported in the geometry context of Fidelity. Instead of working on an entire CAD geometry all through the project, it could be interesting to isolate the surfaces that will be seen by the mesh and then by the fluid. These surfaces are called wet surfaces. Identifying these surfaces can be challenging, especially when dealing with large and complex geometries. The Wet Surfaces Detection tool in Fidelity can help us quickly identify the wet surfaces to be used for AutoSeal. Let's define the tolerance. A surface will be considered as wet by the algorithm if it can be reached from a wet point. Hence, the tolerance value should be the smallest gap size to reach all wet surfaces. Set the Push Detection Toward parameter to help the algorithm to decide how to mark a surface that could be seen as wet or dry. Define the reference points using the Add Wet Point and Add Dry Point buttons. If the geometry contains multiple cavities, we can define extra dry points to make sure we really isolate the wet surfaces. Note that the point coordinates can also be input as XYZ coordinates, clicking at each point in the tree. Lastly, select both the geometry of interest and the reference points in the tree. The information about the number of selected wet-dry points and geometries are shown in the info section of the widget. Set the parallel options if needed and click Apply. Once finished, the tool will create two selections called Wet Surfaces and Dry Surfaces. These local selections are accessible in the tree and can be shown, hidden, or even deleted from the project. With the wet surfaces detected, we can run AutoSeal to close the grille of this car as well as any gaps that may exist between the surfaces of the wet parts. For that, expand the Close Holes button in the toolbar and click on the AutoSeal button. Set the minimum hole size to a value larger than 0 in the AutoSeal widget. It should correspond to the minimal cell size of the final mesh, especially in the vicinity of the holes. If the geometry or part of it is modeled with thickness, activate Geometry with Thickness. Locally, such components look like two parallel surfaces and the distance between the surfaces is small compared to the surface size. When such part exists and are conformal and watertight, checking this option will allow AutoSeal to analyze the geometry more efficiently and thus improve time and memory consumption. We can either create new reference points or use the ones previously created for the Wet Surface Detection tool. Once we select both the geometry and the reference points in the tree, we can then launch AutoSeal in parallel. For this example, the sealing process generated a new assembly called Closing Surfaces in the tree, containing all closing patches. We now have a watertight geometry for CFD mesh generation. Up to now, we have used AutoSeal in the geometry context, but we can also use AutoSeal in the mesh context. After creating a HexPress mesh setup, choose AutoSeal as the mesher in the tree. The advantage of running AutoSeal from the mesh context is that you can close holes of varying sizes in different locations depending on the local mesh refinement levels instead of imposing an overall minimum hole size. However, the setup may take more time depending on the needed number of local refinements. After applying refinements and adding the AutoSeal points, we can launch AutoSeal as we would for a mesh generation. At the end of the process, the closing surfaces will be added to the domain. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.